A projecting snout, broad flippers, and a smooth-skinned shell meet in one freshwater turtle. The combination is not a collection of odd details, it is a body plan found in no other living turtle. This is the pig-nosed turtle, also called the fly river turtle. Insculpta. Its unusual outline is not decoration. Every part belongs to a life spent almost entirely in water. At the end of the snout, the nostrils open near the tip. The projection lets the turtle reach air with relatively little of the head above the surface, while sensory structures in the snout also help it sample its surroundings. That breathing arrangement belongs to an animal committed to water. The forelimbs are broad and flipper-like, producing strokes more reminiscent of a sea turtle than the paddle and claw profile many people expect in freshwater species. Watch a complete stroke. The forelimbs spread, sweep backward, and recover while the body continues forward. Between strokes, the turtle glides, turning muscular effort into smooth, economical travel. The shell adds another surprise. Grey to olive leathery skin covers a genuine bony carapace. Smoothness on the surface does not mean the shell lacks an internal framework. Cross-section makes both layers legible at once. At the bottom, the same limbs can support a slower traverse. In open water, they create lift and thrust. Those two modes show why this anatomy works across the underwater spaces of rivers, lagoons, lakes, swamps, and billabongs.
Pig-nosed turtles belong to the rivers and wetlands of southern New Guinea and northern Australia. Lagoons, swamps, lakes, billabongs and waterholes form parts of a freshwater world shaped by changing water levels.
This species also occupies a narrow place on the turtle family tree. It is the sole living species in Carettochelys, the surviving representative of a lineage that once included more forms across a wider world. But how the shooting Australian changes the meaning of every trait, moves this species, and the loss is not one variation within a crowded branch. An entire living branch disappears with it. Close movement makes the anatomy easier to connect. The snout leads, follows, the forelimbs supply the broad stroke, and the shell carries a firm structure beneath its uninterrupted skin. None of those features works alone. A breathing tip without an aquatic stroke, or flippers without the shell and body they move, would tell only part of the story. Their integration is the real distinction. The big-nosed turtle is endangered, and its population is decreasing. Harvest of adults and eggs, illegal trade, and damage to river habitat place pressure on a species that takes many years to mature. Conservation here protects more than an unusual appearance. It protects the only living species of its family, adapted to a restricted region and carrying an evolutionary history with no surviving counterpart. Return to the full boggy, and the opening puzzle resolves. Snorkel-like snout, flipper-driven locomotion, leathery covering, bony shell, freshwater range, and an isolated lineage all belong to the same coherent animal. The pig-nosed turtle is unlike any other living turtle, because this exact architecture survives in one species alone. Snout, flippers, shell, and freshwater life are parts of the same inheritance. An ancient design, still moving through the water.